how USMA currently gets its power, and a great solution through an improved gas turbine power plant. So, West Point should make its own power. Currently, under the status quo, USMA continues to purchase approximately 10 megawatts of electricity from the commercial grid. This currently costs $9.6 million, and over 25 years, this is going to cost $150.5 million in present value. This represents a significant long-term expenditure with no asset ownership, no cost control, and full exposure to future utility rate increases. Operationally, this option leaves USMA fully dependent on external infrastructure. Grid outages, peak demand events, or regional disruptions directly impact reliability with no backup systems. Option 1 provides no improvement for efficiency, resilience, or sustainability, and locks USMA into a costly, inflexible energy model, highlighting the need for an alternative solution. So what are those solutions? First, we have a baseline gas turbine in option 2, with a compressor, a combustor, and a turbine. This option is very simple, but I like option 3. Option 3 includes a regenerator after the turbine, which increases thermal efficiency and lowering the cost. What's not to love about that? So, more about this system. It improves efficiency and reduces long-term costs beyond what the existing solution can achieve. By developing option 3, we can meet the same power requirement while using fuel more effectively, lowering operating expenses and providing better value over the system's life cycle. This means less money spent over time, lower financial risk, and a more efficient use of resources without sacrificing performance. More broadly, pursuing an improved option ensures that decisions are based on optimized engineering solutions, rather than settling for adequate but suboptimal designs, which is critical for long-term sustainability and responsible system planning. So, looking at it from a cost perspective, first, our option is $4.6 million less than option 1 annually, and $1.8 million less than option 2. The first option, though, the status quo, would be better for short-term savings because of the initial capital cost. However, over the 25-year period, choosing option 3 would save $45 million. That's money that can be invested elsewhere for improvement instead of being spent on energy. So, why a regenerator? A regenerator improves efficiency by capturing waste heat from the turbine exhaust and uses it to preheat compressed air before combustion, reducing the fuel required to produce the same power. Regenerators address heat addition efficiency, while reheat and intercooling address work output and compressor losses. They solve different problems. We're trying to make the system more efficient for West Point, meaning it will take less money out of your pockets and more into training soldiers to fight and win our nation's wars. So, looking at it from a numbers perspective, let's let the numbers do the talking. Our option 3 is the best option because it uses less fuel, it's more efficient, you'll spend significantly less on fuel, and a lower present worth. The lowest present worth for option 3 demonstrates that its improved efficiency minimizes long-term fuel and operating cost, making the most cost-effective design over the system's life. It's clear that option 3 is the best. So, let's look towards the future and what risks are around this option. The primary risks include maintenance complexity and fuel price volatility. These are mitigated through proven designs, conservative performance targets, routine maintenance, long-term fuel contracts, and continued grid interconnection as backups. As USMA's power demand grows, the system's modular design allows additional turbine units to be added in parallel, enabling efficient partial load operation, future expansion, and improved reliability by distributing risk across multiple smaller units rather than a large system. So, to summarize, continuing to rely on power grid cost, USMA spends $9.6 million per year and 150 in over 25 years in present value, while offering no control, limited resilience, and no asset ownership. A regenerated gas turbine provides a more efficient, resilient alternative by recovering waste heat to reduce fuel use and life cycle cost, while improving energy security. Its modular, scalable design aligns with DOW resilience and sustainability objectives and reduces dependence on the commercial grid. Here's our works cited. Here's our acknowledgement. And beat Navy, sir.